So here we have a slightly different view. This is the celestial sphere, which is transparent here, and you can look through it and see the Earth. We see that the Earth is rotated, and here is the Earth's axis, this red line. Now, the projection of the Earth's axis out to the celestial sphere is the north and south celestial pole. And so that's where those definitions come from. It's the Earth's axis. You just continue outwards towards the north and south celestial pole when it intersects with the celestial sphere. Another definition that we need is the horizon, which is the imaginary boundary that separates the half of the celestial sphere that is visible from the half that is invisible due to the fact that the Earth itself blocks it. So obviously, constellations straight through the Earth we cannot see. Our horizon is separating what we can see in principle from what we cannot see. Another definition is the celestial equator, which is the Earth's equator that again is projected outwards. So you can imagine expanding that outwards until it hits the celestial sphere. Final one that will come up occasionally is the zenith. The zenith is just straight up for you, the observer. So each of us in this room have slightly different definitions of zenith, only slightly. But someone, way away in New York would have a more different definition of zenith because the zenith is tied to you, the observer. So these are the central definitions that I wanted to bring up today. Celestial equator, south, north, celestial pole, those are projections of their counterparts on the Earth outwards. Whereas horizon and zenith are tied to you, the observer. They are different for every observer. Nadir down here is going to be the opposite of zenith, but we don't talk about that because we can't see it. So that won't come up in our observations. This is basically just for, so you guys have it. These are the definitions that I just mentioned, but when you are reviewing the slides, if you so choose, at least the definitions are there. All right, so importantly, we can relate the motion of a given star in the night sky to some properties of that motion. So the direction an object rises determines where it sets. And that's really important. If it rises, for example, due east, remember Orion arises basically due east, then it's going to set due west. If it rises towards the southeast, then it will set in the southwest. Same for northeast and northwest. We can also tie these rise and set directions to the amount of time above the horizon. So I mentioned for Orion, let's go back to these guys here, that this motion would be 12 hours. If it rises due east, it will set due west, and that motion will be exactly half of its full 24-hour motion. Half of that motion will be above the horizon, and half of that motion will be below the horizon. So we'll get exactly 12 hours of visibility for Orion. If we look towards the north, something rising toward the northeast and setting toward the northwest will be above the horizon for almost all of its 24-hour motion. So we might get 23 hours out of this star above the horizon. Something in the southeast, you can imagine something rising here in the southeast is going to set over here in the southwest. So it's going to be symmetrical about this line that connects north and south, called the meridian. And so if it rises southeast, sets southwest, it's only going to be above the horizon for a little bit of time. Definitely less than 12 hours. And the further south it rises, the less time it will be above the horizon.
What was the meridian?
So the meridian is connecting north and south.
Okay.
That's when things are transiting. And I will show you the meridian in the planetarium.